All right, so let's talk about the limit of a sequence. So if we have the limit, just like any other limit, if the terms of a sequence approach a unique number L as n increases, that is, if a sub n can be made arbitrarily close to L by taking n sufficiently large, then we say the limit as n approaches infinity of a sub n equals L. All those other words, that's Calc 1, right? That's the concept of a limit, just in general. So as you make it arbitrarily large, infinitely close, then it becomes this number. All right? If this limit exists, then we say this converges. Converges if the limit exists, right? We saw this already with improper integrals, converging and diverging. If the terms do not approach a single number, we say that this diverges. If the terms do not approach a single number, right? Goes to infinity, bounces back and forth between positive and negative, just does not approach a single number. That's what I mean by that. Then that diverges. So we have two choices. It's either going to converge or it's going to diverge, and you need to state what that is. Depending on what your L is, it has two choices. All right, so let's take a look here at example 4. We're going to write the first 4 terms of each sequence. Then we are going to make a conjecture of if it converges or diverges. Or diverges. That's a G. Converges or diverges. All right, here's our first one. Let me scoot this up. I've got A. So we have -1 to the n over n squared plus 1, and that's going from n is equal to 1 to infinity. All right, first 4 terms. That's what we're playing at. So let's write them out. A sub 1. This is an explicit formula, right? Because I have this formula where I'm given my A value starts at n, and then I plug that in, right? It's not saying n equals, but that's what this notation represents. So this is an explicit formula. Okay, so I'm going to plug in a 1 to begin with. So A sub 1 is going to be -1 over 1 plus 1 is 2. My second term is going to be even, so it's positive 1 over 5, because 2 squared plus 1. My third term is going to be negative over 3 squared plus 1 is 10. My fourth term is going to be positive over 17. Now tell me what's happening here. I have -1/2, 1/5, -1/10, 1/17. What do you see happening? What do the numbers look like they're getting closer and closer and closer to, if anything at all? Yeah, it's going to converge. See how I start over here, but it's just up on top, or negative is down here. Then I'm going to go positive, but it's still a smaller fraction. Then -1/10, then positive 1/17. And then as I keep going, it's going to be negative and positive, but these denominators continue to grow. So this is getting closer and closer and closer to 0. Do you see that? The limit approaches 0, and converges. So it converges and approaches 0. Now let me show you this. I have graphs here, because I think it's always nice to see whenever you can see a graph of it. I think sometimes that makes sense. So look at what's happening here, just like we were talking about, right? Here I'm starting down negative at 1/2. Then I'm coming up here at positive, then negative, then positive and negative. It's just getting closer and closer. It's back and forth, but between here, the top and the bottom that I'm looking at, they're both approaching 0. So this whole limit approaches 0, and then therefore it converges. All right, cool. Let's do another one. Oh, I don't want you. Here, let me make it like this. Okay, V is cosine of n pi, and I'm going to go from n is 1 to infinity. So let's list out our terms. A sub 1. If I plug a 1 in here, that's the cosine of pi. What's a cosine of pi? -1. If you don't know it, learn it. 2. If I'm plugging a 2 in, cosine of 2 pi is +1. What about the cosine of 3 pi? What does that look like? Yeah, if I'm here, then I've got 2 pi, and then I'm back right here. So really, we're back here at pi again, so that's my -1. If I'm plugging a 4 in, that sends me back over to the 2 pi spot, and then I've got 1 again, right? So what's actually happening to this sequence? Yeah, -1, 1, -1, 1. It just keeps bouncing back and forth. And so what did we say? In order for it to converge, it has to go to a single number. Is that happening here? No, it's not happening here. So therefore, this is telling me that this diverges. Here's the picture that goes with this sequence. And so that, oh dang, let me try again so that we can see what's happening. So this one diverges because it is flipping back and forth between positive and -1. All right. Oscillating is sometimes what that's called. So it's up here at negative, or down here, I guess, really at negative, then positive, then negative, then positive, then negative and positive. It's just bouncing back and forth. So that's diverges because it doesn't go to a single thing. Okay, cool. I got one more for you here that I want to take a look at along these lines. So example 4C. Here it is. I'm going to move it out of the way so we're not staring at it. So here's 4C. We have, now let's look at a recurrence relation. We just had explicit formula so far. So let's see what this actually looks like in terms of a recurrence relation. So my sequence is going to go from 1 to infinity, where a sub n plus 1 is equal to -2a sub n. And remember, we have to denote our first term here, which is 1. And we know our n value, again, is going from 1 to infinity. So we know that this starts at 1, which is fine because this starts at 1. All right? Okay. So let's do it. My first term here is going to be whenever I take what I'm given. Then my second term is going to plug in what I'm given into my formula. So -2 times 1 is a -2. Then I'm going to take that -2 and plug it in. Then I'm going to take my 4 and plug it in. So our actual recurrence relation here is going to be 1, -2, 4, -8. And what do you see happening with this one? Yeah, where the fractions, as the numbers grew in the denominator, the whole thing went to 0, right? But here, because I don't have a fractions, it's just the numbers, these are getting bigger. You're starting close to that axis, but then they're just running out from there. Yeah, so this one diverges because my graph is going toward positive and negative infinity, right? So take a look at this. Yeah, it's just getting those big numbers. I'm going positive, negative, but I'm shooting way out to positive infinity and way down to negative infinity. It's just going back and forth, and just going to get higher and higher and lower and lower. So this one diverges also. Good. All right, just looking at those patterns. Patterns, patterns, patterns. That's what makes that huge impact. Okay, one more here, and we're not going to solve this one out. This example 5 right here, I just want you to see what's going on. If I want to find the limit, and honestly, next section, we're going to do more of the actual finding the limit. Here's just setting the stage for it. A sub n is equal to 4n cubed over n cubed plus 1. If I want to tell you to find the limit of this before we even look at this, I want to tell you to find the limit of this rational expression. What is it? Yes, and tell me why. Good. So I know that this limit here is automatically, oops, I didn't write this. 4n is equal to 1, 2, 3. That's my bad. I know this limit is going to go to 4 because I have n cubed. When you have the same degree in the numerator and denominator, then you're looking at those coefficients. So 4 over 1, I already know that this limit is going to go to 4. Because if I were to take the limit as n approaches infinity of 4n cubed over n cubed plus 1, we already know that's 4. Now let's look at the graph to prove it. So this one actually has a chart with values on it, which is nice to look at, I think, sometimes. So as I plug in a 1, then you get a 2. As you plug in higher and higher numbers, all the way up to 14, look at this. All it's doing is getting closer and closer to 4, right? That's my limit. Here I'm coming up here, and it's just getting so infinitely close to 4. Over and over. Which, lo and behold, we learned in Calc 1. When you have the same degree, you take those coefficients, and that is where we get that. Right? So we're not getting crazy on this. What you already know about limits holds true, and that's awesome. Yes, enjoy.